Well, I think we'll call that a day. Thank you very much, gentlemen.
Thank you.
Thanks, guys.
Our company is Reclaim System. We generate electricity with wasted heat. A lot of opportunities currently in filling the gaps in the renewable energy market. One of those opportunities is all the buildings that heat with alternative fuels such as wood or corn. And a lot of this fuel is generated, and it's very cheap and efficient to heat your building this way, but a lot of the heat is wasted straight up through the chimney, and that translates in higher carbon footprints and added cost for the consumer. So we capture this heat and we generate electricity utilizing Peltier chips and a feedback effect. And we understand this is a niche market, right? But we don't want you to think that it's limited to just off-power grid cottages and remote outbuildings, because actually a lot of families around the United States heat their homes with alternative fuels, and more businesses are doing that. And the trend is fuel prices, fuel oil is going to trend upwards in cost, so this market's going to grow and grow as that occurs. There's a lot of advantages to our design. We utilize a radial design that maximizes the amount of Peltier chips we can accumulate around our flue area, which is about 400 degrees. We hang 13 coolers off of our thermal transfer material, and we generate electricity in this way. And the convenience of this design is because we have to insulate between the hot and the cold, it also serves as a great replacement for the metal thimble. And what that is that's the unit that must be installed between your combustible wall surface and your heated flue. So the electric flue can replace that. Now we do draw in cold air from the exterior of the building, and we run that cold air over our cooling fins, and this air is heated and returned to the inside of the room. This increases the efficiency of the wood stove by capturing that heat and putting it back into the room. And an additional benefit to this is the air also pressurizes the atmosphere inside the room, and it reduces those drafty feelings. So we're adding value through comfort. But most importantly, we're generating electricity all at the same time without any external energy sources. And this is truly free energy because it's already being burned, it's wasted up the chimney, we're just capturing it, converting it into electricity, and improving the efficiency of the existing equipment. Our design is modular, so you see in the radial picture, you don't have to purchase the entire series of modules. You can buy the housing with one module at a time. This makes it affordable and scalable for our customers. And it's a continuous operating device, so it's generating electricity both during on-grid performance and off-grid performance, so it's truly energy security. You don't have to worry about your device not working because it's always in operation. Our competition for emergency power generation is obviously gasoline generators. These are relatively cheap for $600. You can pick one of these units up almost anywhere today. The only problem is extremely loud. They annoy your neighbors, and even the owners can't sleep when one of these is running in the background. And you have to transport the fuel for this. This means loading up flammable liquids into your vehicle, gasoline, transporting it to your garage, and storing it there. But that doesn't stop there, because when your generator runs out of gasoline, now you must transport and fill a hot generator. It's dangerous and it's very inconvenient for the owner, and it's expensive, because if you calculate 5 gallons every 8 hours to operate a generator, it's not a good solution. It's run about $45, $50 a day, so very expensive. Solar is a great solution because the sun is a big ball up there in the sky, an abundant energy source to capture, but we're all from Michigan, so we know we don't have sun this time of year. Obviously, the power consumption is much reduced during the winter periods, and installation, even though it looks straightforward, it usually requires contracting a professional to install it, adjust it, and make it operate. And if you try this do-it-yourself, you're usually tweaking it over days, sometimes weeks, and even months. Now, the electric flue is a true do-it-yourself installation. As you can see, we have standardized ends on the flue. It literally clips into your current existing system. My 12-year-old could install this in about 10 minutes. It's continuous operation, so as long as your wood stove or corn stove is running, you're producing electricity. So it's It's reliable, it's continuous, and you don't have to worry about it breaking down. It's seasonal, obviously. We don't run our wood stoves in the summertime, and it's regional. I doubt we're going to have a market in Miami or be selling electric flues in Dade County. There's 12 million wood stoves in operation in the United States today. 800,000 new wood stoves are sold every year. Now, we're not trying to target 5% or 1%. All we want is 1/10 of 1% of this market, and we'd be hugely successful. And our company's strategy is to utilize social media, and I know that sounds cliche, but it's very important for the electric flue because it's not easily recognizable and identifiable as what it does. So it's going to require some buzz and generating some interest and education for our customers. So we're developing this around our e-business strategy, which is web-based, so we don't have to incur those costs of the brick and mortar retail stores. But I do want to stress that retail stores are very important for our products, so we're partnering with retailers and wholesalers of wood stoves and corn stoves to get our product out on their showroom floors. Our initial target market will be Michigan, South Michigan precisely, and we're going to be constrained to that market in the first year so we can collect the customer feedback and contour our product to fit their needs and wants. So we can use that before we go coast to coast. Now back to retail stores, and I want to discuss a little bit about this because this is really critical, is to get this product on display and in the stores. My discussions with Mark Wrench from Kalamazoo Fireplace and Grill, he was really excited about the product, and he was so excited, he was like, how can I get this on my showroom floor? And then he explained to me that wood stove retailers, they operate their wood stove, their new models on their showrooms to heat their facility. He says this would be great to operate the electric flue on top of my operating wood stove because it would drive customer interest both to their new products and our products, and this is a synergy win-win. It's a truly win situation. Now Dan from the Energy Mill, he had sort of a different story for us. He was very excited about the product, but he says his customers are really concerned with their corn stoves. Now corn stoves are different from wood stoves because they require power to keep operating. So when the power goes off, the corn stove stops working because it requires a blower to burn the fuel. And he says their current solution is a battery backup system that lasts about 8 hours. And this frustrates his customers because if your power goes out, it's kind of disheartening to realize your heat's going out in 8 hours. And he thought this would be exciting because this would offer continuous operation for a corn stove. It was supplemented with some battery power. Now the one strange item, and I was approached by Amber from Champion Tree Care, they provide cordwood and corn for these alternate fuels, and she was excited because she's always looking for new exciting ways to save her customers money and increase the efficiency of their heating devices. She was like, you have to make me up a brochure because I need to send this out to my customers this year because the season is almost over. So very interesting development on that front. So what we're looking at is we've already have our web presence developed, educating our customer through our blog, and we're going to do the make to order, which is a small batch process for our initial units so we can react quickly to customer wants and needs. We're keeping our design with a modular design so our customers don't have to purchase a full-blown unit. They can purchase electric flue with only one module and expand it as their needs grow. But this is really good because this keeps our customers coming back to our sites and repurchasing items and seeing our newest, latest offerings. So what we're asked for is $600,000, and that'll get us at a break-even point in year 3. And it's pretty respectable ROI of 72%. But it is a leap of faith. We have some assumptions here, and that's 20 units sold first year 2012. And this assumes 500 units in 2013 and a 50% increase in sales thereafter through 2016. Current team about Reclaim System. My name is Aaron Tardy. I have 10 years of manufacturing experience in metal castings. I have an additional 10 years in business analytics and information systems. Sergio Capoletti is our marketing guru. He is very enthused and excited about marketing new products, and this is where we tap his experience. And Olivia, well, she's a business owner currently, so she's our Morpheus. She's taking the red pill. She lets us know when we're going off track and realigns us to what our customers desire. What we need is electrical engineer and an AutoCAD designer. And our company is currently partnered with Dr. Parker and Dr. Hall from Western Michigan to set up graduate programs for the summer semester. And we have these currently in place. The only problem with that is this is a semester timeline. So it's going to be semester to semester, and our company wants to shrink that timeline and be much more aggressive. So what is our timeline? We want to complete our prototype in testing by March 31st. And during this same period of time is when we're generating our buzz through our blog and more excitement to build that first mover customer base. We're also looking at building 10 units by July 1st, and this is really important because during this time we're also partnering with these retail locations and showrooms so we can place our products and have them operating on their showroom floor. And we're already in that process, and we've got 3 companies lined up currently. Delivery of the demo units must occur by August 31st. And this is critical because we want the electric flue on these stoves when they turn those stoves on so it's fully functional as those customers come in and we build this excitement. I do want to add one piece to this, and this was my conversation with Dan at Energy Mill. While I was talking to him, he was really excited and wanted one of these units for his showroom immediately. And he told me something that set me back on my heels. He said, Aaron, if you had 20 of these units, I could make 20 phone calls and sell 20 units today. That's how much his customers are screaming for a solution for their corn stove. And I realized during this whole process, we need to develop an emergency scalability plan, because the worst thing for our company and our business is to be inundated with orders and not able to act and move on those orders. So that is a huge concern. At this time, I'd like to invite you all to visit our website. It's www.electricflue.com. And please add in our blog your comments, criticisms, whatever, because we're going to take every piece of feedback to heart, and that's what we use to contour our product to meet our market. And your opinions are extremely valued. So at this time, we'd like to take questions.
Just real quick, interesting idea. The whole thermoelectric space. I understand there's a lot of buzz around thermoelectrics in general, and we've looked at these as a potential investment opportunity for General Motors for exhaust systems and feeding power back into batteries and stuff like that. But the issue always is they're really very inefficient, and so when you compare them to gas generators, I wonder, is that a fair comparison, or what's the power output like from one to the next?
Okay. If you compare power to power, you're not going to approach the efficiency of a gas generator. But a gas generator cannot do what the electric flue can do, which is it adds value through reclaiming that heat also, and it's continuously operating. So what's the struggle with your generators knowing, hey, will that start when I have a power outage?
I'm just curious, can you give me some idea of what the power output is from gas generator versus a thermoelectric module?
The generator I quoted is like 6,500 kilowatts.
Right.
This electric flue fully populated will be 250 watts,
okay,
with a later model up to a kilowatt with
okay,
a design change.
Okay, so you're talking probably like one appliance, basically.
That's correct.
Powering. Okay.
Plus running the fans and all the internal workings and components of wood stove and corn stove that keep it
right. Yeah, to me the corn stove argument is compelling. I was just curious, just from a power output standpoint, how it compared. Okay.
Is that one module?
This is
right here.
Yeah.
This is a thermoelectric module
that you're familiar with.
Sure.
and the housing is right in here, and then on top of that we have cooling towers with cooling fins. This is passively cooled. And we're also exploring the possibility of having a liquidly cooled with glycol, but right now we feel like this was the best choice for now, because it was a bit easier to engineer and to basically assemble for you. Of course, in time, we would be also relying on smaller units. Now, if you can imagine this without the fan on the back, this would be a smaller unit for cooling, which would allow us to reduce and resize the whole unit. So it wouldn't be quite this bulky.
Could you talk, I'm familiar with the technology you're talking about. Could you just talk a little bit about the efficiency? So if you make 250 watts electric DC, and it's 5% efficient, your corn stove must be very big.
Here's the hook on the corn stove. Corn stove has peak power to start the fan, but then it drops to 1 amp of draw.
Okay.
So for the corn stove model, we are going to have to incorporate a battery system for that peak power.
Oh.
And then the 1 amp can be exceeded, so it will run the blower plus trickle charge that battery for the next cycle time.
I look at 12 volt system,
Yes.
so 1 amp, 12 volts, 12 watts.
Oh, boy. The wattage is, it's just multiplying the other, yes.
Okay.
There's my limitation as an electrical engineer, straight math.
Cool. Okay, I don't know if this is the appropriate question to ask, but does it work? Is that a working prototype?
Negative. That would be, but we cut a hole in it so you can see. But that prototype could actually function just by putting it on a wood stove, albeit it wouldn't cool efficiently. It wouldn't, right now we have 3 legs milled. So, I mean,
Got it, so you don't have it both.
yeah.
So is there any, is it just, plug and play in the sense you just drop it in, or there is more customization that's required for it? Are there any safety elements that you have to take into account when you're using it, like different types?
This design is literally plug and play. And by design, it will hook into to the distribution system. But this is our minimal viable product, so we didn't want to be got off on a tangent designing a distribution, a box or whatever. Safety issues, there is none. It's actually as safe as a through-wall thimble because it requires internal insulation, and the external devices are cool. So the housing's insulated and the internal's insulated, so it meets that double wall requirement.
So even as a requirement, is that, is it somebody's, is monitoring or putting some standards in these kind of stoves and things like that are being sold, or?
That's a very good question. There will be, before we can advertise it as a replacement for the thimble, there will be some certification I'm sure our company will have to go through. So initially, we will not address that as a solution. We will use the freestanding on the stove solution before we receive that certification.
So how do you see this being mechanized in the product that you're actually taking to market? I mean, how much additional electrical integration are you going to do? And what's the plug going to look like? How are you actually
Yeah.
It's a
feeding?
very good question because from the presentation, you see we need an electrical engineer. Because the tags operate based on load, and they heat up and generate power at different levels. So the electrical switching has to aggregate a lot of tags to get to the 12 volts and then split those off when they get up to temperature. That is why we require some electrical engineering design. That unit will be designed separate from the electric flue so that we're only running one cable to that architecture. And that cable will be part of that design, so it's going to be a series of wires.
So would you envision that as an outlet, basically, like a supplementary outlet?
Yeah, well, different solutions based on, tiered to our specifically for our customers. Currently, I have one customer that he would like this unit, actually, because he has a solar wind combination system, and they're attached to his barn, and he uses them, and he wants that supplemented energy when he runs his wood stove. And he has a battery bank and all the, same sort of connections that this would utilize for recharging that battery bank.
Can you go into a little bit more detail about the IP around your technology?
As of right now, our funds, we don't have enough funds to get an IP to patent this or to defend it. But maybe later on we will.
So it's like trade secrets, is that how you're protecting it?
Patent pending. Investing $40,000 to patent to try to defend it, I can't get my head around those numbers.
We have 2 minutes left for a couple more questions.
So manufacturing, did you talk about that, how you're going to manufacture, or you have partnerships around that?
For that, I would say we're gonna outsource the production of the components and probably gonna buy them off the shelf, of course, from wholesalers, so. Then for the first couple of years, we will be producing most of them ourselves. We have a manufacturing facility that could open on some of Olivia's property, and it is already properly zoned, so that would be an advantage. And again, once we reach critical mass and we get to a point where we would have to make, where the three of us wouldn't be able to keep up with making them, then at that point we would have to probably expand our manufacturing facilities.
Well, in terms of your raise, wouldn't it be, because the problem right now is that as the patent law has switched over to first to file as opposed to first to use, if you guys are raising money, why wouldn't you raise money to get your property patented and your protection in there? Because if somebody can take your design, re-engineer it, and put it in the patent before you do, it's theirs.
Our concern with that is that we don't see anything but the design as being patentable. So yeah, we'd have to patent the design, but I guess we just have to look more into it and probably contact a patent attorney and try to.
Well, just in terms of the funding that you're looking for, you can just sort of add that
Yeah,
to the
that's-
top. Because that's a viable, I mean, anybody who's going to invest in it is going to want you guys to have that.
My largest concern, just from the design perspective, is the stamping for the housing. Obviously, that's going to be a large cost, but the beauty is the tooling for the cooling towers already exists, and those are actually developed for processors, so I'm sure we can get some economical redesigns to fit our specific need, because those are literally off the shelf today.
What's the cost of your system, and how's that relative to, I've never bought a wood stove before, so.
I'll speak to that.
Well,
Go ahead.
The cost of a wood stove can range anywhere from $1,000 to $6,000. The cost of the base model electric flue, we're ranging around $900 to $1,100, and each additional module will run about $250.
that would be the sales price.
Does that include the supplementary electronics that you need to
No.
feed this back into the?
No,
Okay.
that does not. It's not uncommon, it costs $1,400 to add the flue pipe to your chimney to install your wood stove. So, I mean, it's not a bad price point.
We may need to leave this up in the air at this point and not just call it that we're finished.
All right.
Thank you.
Thank you.